Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 19, remove nth node from end of list. This is a classic problem often seen in coding interviews, and it's categorized as medium difficulty. We're given a linked list and an integer n. Our task is to remove the nth node from the end of the list and return the head of the modified list. Sounds straightforward, right? But there are some interesting twists and nuances we'll explore. Think about edge cases like an empty list, a list with only one node, or when n is larger than the list's length. These are crucial considerations we'll address throughout the tutorial. We'll explore different approaches, ultimately landing on an efficient solution. So buckle up and let's dive in. Understanding with examples. Let's clarify things with some examples. Suppose we have a linked list 1, 3, 4, 5, and n is 2. That means we need to remove the second node from the end, which is 4. The resulting list should be 1, 2, 3, 5. Now, let's try another one. List 1, 2, and n is 1. Removing the first node from the end leaves us with just 1. And what if the list is 1 and n is 1? We remove the only node, resulting in an empty list. Understanding these scenarios is vital for writing robust code that handles all possible inputs. Let's see how we can approach this problem systematically to avoid any unexpected behavior. Brute force approach. One naive approach is to first traverse the linked list to find its length. Then, we traverse the list again, stopping at the length minus nth node and removing it. This method is simple to understand, but inefficient. It requires 2 full traversals of the list, resulting in a time complexity of O of 2n, which simplifies to O of n. While this works, it's not the most optimal solution. The space complexity is constant, O of 1, as we are not using any extra space proportional to the input size. But can we do better? Absolutely. Optimal solution. The optimal approach uses 2 pointers. We'll call them fast and slow. Initially, both pointers start at the head of the list. The fast pointer moves n steps ahead. Then, both pointers move simultaneously, 1 step at a time, until the fast pointer reaches the end of the list. At that point, the slow pointer will be positioned at the n plus 1th node from the end. We simply remove the next node after the slow pointer to remove the nth node from the end. This approach elegantly solves the problem in a single pass, significantly improving efficiency. It's a clever use of pointer manipulation in linked lists. Code implementation. Let's see the code in Python. We'll define a function remove nth from end that takes the head of the linked list and the integer n as input. We'll first handle the edge cases of an empty list or a list with only one node. Then, we'll initialize the fast and slow pointers. The fast pointer will advance n steps. After that, both pointers move together until the fast pointer reaches the end. Finally, we'll adjust pointers to remove the node. The code will be clean, efficient, and easy to follow, implementing the algorithm we just discussed. I will add comments to explain every step clearly. Time and space complexity. Now, let's analyze the time and space complexity of our optimal solution. The time complexity is O of n, because we traverse the linked list. This is a significant improvement over the brute force approach. The space complexity remains O of 1, because we only use a constant amount of extra space for our pointers. So, we've achieved both time and space efficiency, which is the hallmark of a well-optimized algorithm. We've significantly improved the efficiency by using the 2-pointer technique. It is an excellent example of optimizing algorithms using clever data structure manipulation. Engagement break. So, what did you think of that solution? Pretty neat, huh? If you found this helpful, don't forget to smash that like button and subscribe to the channel for more LeetCode tutorials and coding challenges. And let me know in the comments if you have any questions or alternative approaches you've tried. Let's keep the coding community strong and collaborative. Your feedback helps me to improve future videos and create even better content for you all. Now, let's wrap things up. To summarize, we've successfully tackled LeetCode problem 19, remove nth node from end of list. We started with a brute force approach.